This is for further maths. We're going to look at exercise 17G, question number 8. So this is to do with scale factor of volume, but it's a bit more complicated, okay? So we've got an inverted cone on the right, and it has a capacity of 100 meters cubed, and it's to be filled with water at half its depth. Find the volume of water. Okay, so I'm going to draw the two cones. So we've got the big cone and the part of the cone that's been filled with water. I know the capacity of the larger cone is 100 meters cubed, okay, so that's the volume. I don't know what the capacity of the smaller cone is, but I do know that the height of the larger cone, if I call that h, then the capacity of the height of the small cone, which is the part that's filled with water, it's only half of the bigger cone, so it's half h. From the h's, I could actually get the scale factor. Okay, the scale factor is old divided by new. Okay, so I'm going to call the big cone the old, the small cone the new. So the height of the old cone is h. No, sorry, the height of the new cone is half h. The height of the small cone is h. If I divide half h by h, I can cancel the h's. I get a half. Now, you can do that on your calculator as well. You can just literally type in half x divided by x, and you should get a half. Okay? So, now I want to find, I want to get a scale factor for volume, okay? We're actually scaling down because we're going from a larger shape to a small shape. So, our k factor is a half, which makes sense. It's a number that's less than 1. Okay, because half is the same as 0.5, which is less than 1. So, the new volume equals the k cubed, because when we're scaling volumes, we need to use k cubed, times the old volume. Okay, the old volume happens to be 100. Okay, because that's the volume of the larger cylinder or larger cone. So k cubed would just be a half cubed. So if I multiply the old volume by the volume scale factor k cubed, I get my answer. So when I calculate that on my calculator, I should get 12.5 meters cubed. Okay. So key idea behind similar volume and area problems is, first of all, find the value of your k. Okay. Once you get your k, the rest is very simple because you can work out what your you can work out by timesing by either k squared or k cubed, depending on whether you have length, area, volume, to get the new area, length, or volume. So hopefully that helps. In this case, this happened to be, we're trying to find a new volume. So the new volume is k cubed times the old volume, okay, which is 12.5 meters cubed.